All right, welcome back. It's finally time to start getting our hands dirty with Python. In today's video, I'll be introducing you to the Python programming language. As of today's date in 2023, Python is arguably the most popular programming language in the entire world. Python has a very clean and intuitive syntax, which helps it stand out as a universal language that's both beginner-friendly and powerful enough for seasoned developers. Python is widely considered to be the most flexible language available to developers. It is a leading tool for web development, game design, data science, web scraping, data visualization, and machine learning. Due to its wide-reaching popularity, we have open access to enormous libraries such as Django, Pygame, Pandas, Beautiful Soup, Matplotlib, and scikit-learn. So before we can dive into the world of Python programming, we need to first clarify what exactly a program is. In the world of computing, a program is like a recipe. It's a sequential set of instructions that a computer follows to achieve a desired result. Just like how a chef moves step by step through a recipe, a computer systematically processes each instruction in a program, transforming inputs into outputs and bringing the creator's vision to life. And just as recipes can range from a grilled cheese sandwich to tornado rossini, programs can be a few lines long or span millions of lines, creating everything from basic calculators to sophisticated AI models. At its core, the essence of programming lies in the intricate dance of logic and creativity, guiding the machine to not just compute, but to solve, innovate, and even learn and inspire. Delving deeper into the realm of computer science, when we run a program, we are essentially instructing the computer's processor to execute a sequence of operations in binary, the language of ones and zeros. This execution process involves fetching, decoding, and then performing the operations, translating our human readable code into tangible actions or results on the machine. But really, the most vital takeaway for a beginner is this: computers are inherently precise and literal. They execute instructions exactly as they are given in the exact order that they're presented. Unlike humans who might infer meaning or fill in gaps based on context, a machine will faithfully act on your commands, whether they lead to success or an error. Therefore, as a new programmer, exact precision is key. Okay, before we actually dig into Python, let's get a few of the more mundane things out of the way now. First, Python has a set of reserved words, also called keywords. All we need to know right now is that these are special words that mean something very specific to Python. You can think of these words as calling upon and running some hidden program that you can't see. Therefore, we can't use these words when we begin creating our own variables and functions. At any time, you can request for Python to provide you with a full list of its keywords to refresh your memory using the syntax you see here. But this involves importing a library, calling upon an attribute, and utilizing the print function, which are all topics we'll cover later. Second, Python is case sensitive, so pay attention to when you use upper or lowercase letters. Finally, spacing matters, indentation matters. Other languages rely upon specific characters to define subblocks of code, but in Python, indentation can create code hierarchy. Okay, with that out of the way, let's start with the basic data types that we'll be working with. There are really 4 types of data that we need to be familiar with when we're using Python. We have strings, which is a series of text. we indicate string data using the single or the double quotations. We have integers, which are whole numbers without any fractional component. Here, we can see that we can use Python just like a simple calculator. We have floats, which are integers that also have a fractional component, like you see here. And finally, we have booleans, which simply have two possible values, true or false. Okay, now let's talk about variables. As the name implies, a variable is anything where the value might vary. This is different from a constant, where the value remains the same, such as a number or pi. For the most part, Python doesn't come preloaded with variables. It comes preloaded with functions, which I'll talk about later, and constants, like numbers. But we create the variables. We define a variable in Python using the equal sign. Here, I'll create a variable called player and assign it the value Rafael Devers. However, I want to point out that using the equal sign is actually a bit confusing. I don't want you to think of the equal sign the way you would in mathematics. Rather, think of it as an arrow pointing from right to left. A variable in Python is like a box that may have some contents inside. On the left of the equal sign, we have the name that's written on the box. On the right of the equal sign, we have the contents of the box. At any time, we can take these contents out of the box and put something else inside. In fact, the box can even be empty. When we create a variable, ultimately we're instructing our computer to reserve some bytes of memory for holding some data. We are then giving that bit of memory a name so that we can later call upon it, use it, change it, or even delete it. Then we are putting some information into that memory store. Finally, there are a few rules that we have to keep in mind when it comes to creating our variables. First, names must start with a letter or an underscore. Second, they can only include letters, numbers, or underscores as characters. Third, there is a certain set of words that we cannot use as our variable names. We discussed earlier that these are called reserved words or keywords. And finally, remember that names are case sensitive. Okay, let's create some more variables. First, let's put Rafael Devers back into the player variable. Remember, we previously used the reserved word none to instruct Python that we wanted the player variable to be empty. Let's update that bit of memory and put our string back inside. Next, I'll create two more variables called at-bats and hits. I'll give each variable an integer as its value. Finally, I'll instruct Python to create a fourth variable, but this time I'll calculate its value based on the variables that came previously in my program. I'll create a variable called batting average and assign its value as hits divided by at-bats. You can already start to extrapolate from this simple day one example to see the power that programming offers data science. I no longer need to manually update batting average for Rafael Devers. It is now calculated for me automatically as his raw statistics change. Okay, now let's talk about some basic functions that we need to know as Python beginners. First, let's define what a function is. The best way to think about functions is that they're like mini programs that are mostly hidden from us. To give you an example, imagine you had a robot that required precise, step-by-step instructions to perform any basic task, such as pouring a glass of water. Over time, you realize that pouring the glass of water is something you want this robot to do regularly, and repeating the same sequence of instructions is wasting your time. A function is simply saving these instructions somewhere in your computer's memory so that you can call upon it anytime you need it with one simple line of code. You can recognize a function in Python syntax as a name followed by a set of parentheses. In a future video, I'll go over how to write your own functions, but for now, we're going to leverage some of the many functions that Python gives us for free with the basic Python library. Certainly, the most common function for beginners is the print function, which simply instructs Python to print out some form of output. Here, I'll ask Python to print what we have stored inside the player variable. We see that the string Raphael Devers is printed. We can verify that this is a string variable by using the type function. Here, we'll ask Python to return the type of data stored inside the player variable. But importantly, we're going to ask Python to print this information by embedding our type function within the print function. So you see we have nested functions, which will become very common. To be clear, in Jupyter, Python will print the information it returns without the print function. However, I want to get you in the habit of using the print function anyways, because it will better translate to situations where you are working outside of the Jupyter notebook, or in situations where a single cell has more than one output. Now let's print batting average. In case it's not obvious, we're working with fictional baseball data at the moment. It's customary with baseball data to round to 3 digits. So let's use the round function to achieve this. Further, we're going to overwrite the batting average variable so that what is stored inside is the rounded version of this number. We can do this by simply using our equal sign to put something new inside the box. Finally, we have to tell Python how many digits to round to. We do this by calling upon what's called an argument. An argument is simply some additional information that we can provide to customize how the function works. We put our arguments inside the parentheses. Most functions accept one or more arguments, but these are often not required. For example, if I run the same syntax as before, without the argument of 3 for decimal places, Python will assume I want to round to 0 decimal places. Okay, now let's get a bit more sophisticated. Let's build an interactive program. That is, let's build a program that interacts with the outside world to retrieve information about any given player. When we get a bit more advanced, we can use various data mining tools to achieve this. But for now, we'll request this information to be delivered to us by a user. We'll do this using the input function. The input function takes a string of text as its argument. It then presents this string of text to the user, requesting the user to provide it some information. Let's ask the user who their favorite player is. The problem with the approach that we just performed is we requested the information, but we didn't store it anywhere. So now it's lost. Remember, we need to instruct Python on exactly what to do. So this time, we're going to request the user's favorite player, but we're going to store this information in our player variable, overwriting Raphael Devers. Let's go a step further and ask our user to give us some basic information about their favorite player. Now, a logical next step would be to calculate the batting average again based on the information we just retrieved. However, we have one small problem. All user input is recognized by Python as string data, even if they fed us a number. We could see this by again using our type function. Python cannot perform a mathematical operation using string data. Here is the error you could expect if you overlook this. Therefore, we must convert hits and at-bats into either integers or floats. I'll convert them to integers. Now we can calculate batting average for our user's favorite player. Let's print this information out and round it to 3 digits. Note, when we do this inside the print function, we are not overwriting the information that we have stored inside of our batting average variable. This will only be overwritten when we use the equal sign. Remember, that equal sign is like our arrow telling our computer what to put inside that bit of memory. If I print out batting average again, we'll see that the full unrounded number is still intact. Finally, let's talk about Boolean variables. As I mentioned before, a Boolean variable is a variable that has one of 2 values, true or false. This might sound pretty simple, and it is, but we're going to use Boolean variables once we get into conditional code. I'll give you an example of this conditional code at the end of the video. But to demonstrate how a Boolean variable looks, let's first create a new variable. This variable will represent the overall batting average of the MLB. Next, we'll create our Boolean variable. We'll design this variable such that it is true if Dansby Swanson's batting average is above the MLB batting average, and false if his batting average is equal or below. We'll name this variable good. When we print this variable, we see that it is a Boolean with a value of false. Also, keep in mind that true and false are reserved words in Python. We could see this by storing the value true inside of our good variable. Now, when we print this variable, we see that it's been overwritten. Remember that our equal sign does not mean equals. It's actually an arrow for storing information in a variable. That means we have to use different syntax for referring to the mathematical notion of equivalence. Take a look at this example where we create another variable called exact average. We want this variable to be true if Dansby Swanson has an average that is exactly the same as the MLB average. Here we have to use a double equal sign. This double equals indicates the mathematical use of equivalence. Anytime you want to refer to true equality in Python, you should use these double equal signs. For a more practical example of when you might utilize a Boolean variable, assume for instance you're building an online store and you want to offer free shipping to customers if their total purchase amount exceeds $50. We can create a Boolean variable called free shipping, which will return a value of true if the purchase is over $50 and false if their total purchase is equal or below $50. In this scenario, the right side of the equal sign is simply a statement that may or may not be true. The truth of this statement is stored in the Boolean variable. Importantly, Python can recognize this as a Boolean variable automatically. No special coding is necessary to define it. Finally, I included a sample of the conditional code to give you a preview of a topic that we're going to explore in detail in a later video. Okay, so that about does it for this video. Today, I introduced you to Python's common data types, how to create and manipulate variables, and some basic functions. In the next video, I'll show you how to start manipulating string data. See you then.